Hello everyone, this is the sixth lecture of the data science series using R Python, and the today topic is naive Bayes classification. Naive Bayes is the simple yet powerful algorithm widely used for the classification task. It is based on the Bayes theorem, which describes the probability of an event based on the prior knowledge of the related event. Naive Bayes assumes that the features are the conditionally independent given the class label, which simplifies computation. There are some key features of the naive Bayes. First is the probabilistic models. Predict the probability of a class given the features. Second is independence assumptions. Assumes all features contribute independently to the outcomes. Third is the efficient. Work well with the large dataset and is computationally efficient. And the fourth is the handle discrete and the continuous data. Can be updated for the both types of data. This is the Bayes theorem. P into C upon X equal to P into X upon C into P into C, P into X, P into C by X equal to frac P into X upon C, P into C, P into X into P into XC upon X equal to P into X, P into X upon C into PC. P into C upon X into P into C upon X into P upon C upon X equal to is a posterior probability of class CCC given XSS. Second is the Px upon C, Px upon C and Px upon C likelihood probability of XXX given class CCC. And the next is the P into C, P of C prior probability of a class CCC. P of X and P of X evidence probability of the data XSX. Naive assumptions. The features X equal to these are the data are the conditionally independent. This simplifies the consumption at this type of data. So next, the types of the naive Bayes classifier. There are the three types of naive Bayes classifier. First is the Gaussian naive Bayes, second is the multinomial naive Bayes, and the third is the Bernoulli naive Bayes. Let's explain one by one every types of naive Bayes classifier. First is the Gaussian naive Bayes. Assume the data is the normally distributed. Second, suitable for the continuous features. Third, likelihood. These are the example. Now second is the multinomial naive Bayes. It is used for the discrete data such as text classification. Second point is suitable for the count data like word frequencies. Third is the likelihood is calculated based on their features count. Third is the Bernoulli naive Bayes for the binary or the Boolean features. First point, suitable for the binary classification task. Second, likelihood P of xi into C, P of xi into C, P of xi upon C depend on whether xix underscore ixi is present or absent. There are the few applications of the naive Bayes classification. The first is the text classification, second is the medical diagnosis, third is the recommendation system, and the fourth are the fraud detection. First, text explanation, text classification, spam detection, sentimented analysis, and the document categorization in the text classification. Second is the medical diagnosis, predicting disease based on the symptoms. Third is the recommended system, classifying items or user based on preferences. Fourth is the fraud detection, identifying fraudulent activities. There are some advantages of the naive Bayes classifier. First is the simple and fast to train. Second is effective with a small amount of data. Third is the perform well for the text-based application. These are the disadvantages of the naive Bayes classifier. Strong independency assumption may not hold in the real world scenarios. Poor performance if features are the highly correlated. Sensitive to zero probabilities, require smoothing techniques like the Laplace smoothing. Let's try to understand with the example. these are the example of the new Bayes classification. First of all, from sklearn.data set import load IRES. From sklearn.model selection import train test split. From sklearn.newBayes import Gaussian NB, and from the sklearn.matrix import accuracy dot underscore score. First of all, load the IRS dataset. Initialize the value irs.data in X and iris.target into Y. And the next step is split the data into the training and the training dataset. And the third step is build a Gaussian Bayes classifier. Let's see the output of this code.